Lecture 9b, the CHRISTOFFEL symbol is not a tensor. Let's continue. This is a long demonstration about to lead to the result, which will show that CHRISTOFFEL symbol is not a tensor. Giving a coordinate transformation xi, x tilde p, these are labels at point P. This is the tilde gamma, in this case, the CHRISTOFFEL symbols in terms of gamma k ij. You see, I want to transform this in terms of this. Recall the CHRISTOFFEL symbols are defined via covariant derivative of a vector. Okay, this is a covariant derivative of a vector, partial xj vk. This is gamma, the CHRISTOFFEL symbol kij vi. Components of the covariant derivative, j and k are free indices. You see, j and k, you see here, j and k, j and k, j and k are, in this case, free index. Step 1. Transform the vector components. Attention, this is Jacobian, the inverse of the Jacobian, partial derivative x tilde or the xm, partial xm. And VR, okay, the transformation of the components of this vector VR into the VM. And now you see here, this is the inverse of Jacobian. Okay, as we derived in lecture 8. Okay, attention, Vm is a function of x, which is a function of x tilde. Exactly what you did in lecture 8 here. Now you want to compute the derivative of Vk, V tilde r, with respect to the new coordinates x tilde k. So this is an expression that I want to compute, partial of v tilde or respect to x tilde k. Now you see there is a relation between VR, okay, and Vm, okay, as we showed also on lecture 8. So we just substitute, you see over here, this partial VR tilde dx cubed, this xxk. You see there's a VR over here, that's a VR over there. I just substitute V tilde r and plug over there. Again, attention now, x function f tilde is the Jacobian J, okay, capital J. And this is the inverse of the Jacobian. Exactly what we did, I repeat, on lecture 8. Lecture 8 is crucial for you to understand this manipulation, okay? So let's apply the product rule, okay? Partial of V tilde r respect to x tilde k. You see, that's in this case, I apply the product rule where? I applied here, okay? I have, in this case, two terms. The first one, a derivative, second derivative here, Vm, plus I repeat this and take the derivative of Vm. Exactly what I did over there. You see? Two terms, the first term and the second term. Now, attention, here, you see, I have this mark here, red mark, okay? I just wrote from here, and it's clear that I use the chain rule, okay? Use the chain rule. So it's clear what is written here. Then I substitute just over here and write down and this line here. So second derivative x tilde r, x tilde k, xm. You see, I just substitute. It's quite easy, you see. That's a substitution. Now Vm, attention now, this is a capital J, that's Jacobian, okay? Lecture 8. And plus the third term, you see, I just mark over here, okay, and substitute over there. Okay, this one is a substitute over here, then I write down here. Now, attention for this blue one mark here, okay? So step 2, covariant derivative of the new coordinates. You see, this is covariant derivative. What's the new coordinates? Are the tilde coordinates. You see, I just write down the definition of covariant derivative. Now you see, this blue one is just all these two terms. I substitute just over here, and this is the long. See, you just again pick a paper and write on, okay, what is written over here. You see that the development based on lecture 8 is quite clear. Now, then I substitute. See, quite easy. The blue one, you see, this term and this term, I just substitute over here, which leads to this long term over here. You see, there's the two terms here plus the final one. Now again, you see, this one, the green one over here, you see, V tilde P, lecture 8, can be transformed on VK. You see, no tilde on VK. And this is relation also in lecture 8, which is crucial for this development. So I just then, I substitute this one over here and write down the blue one again, plus what I derived over there. And remember, partial x tilde p, xk, is the inverse of the Jacobian. You see, this is j minus 1. So it's clear what's written here. So since this is a long derivation, now I'll continue the next lecture, 9c. Again, I recommend you copy this, you see, and then follow each step what I'm talking about, okay, just easy. The lecture 8 is crucial to understand all of this, and follow the colors. See, the red color here, you see, this is the red color here, this is the inverse of Jacobian, and then you see this partial derivation, you see. This I'll continue on lecture 9c. The goal is to show that CHRISTOFFEL symbol does not behave as a tensor. You see, we will see that. That's our goal. That's it.